Okay, this video is about probability distributions. All right, we start with definitions, but as usual, I always like to just get into it and I'll come back to the definitions. So this right here is a probability distribution of two dice. Well, what does that mean? This is a probability of getting 2, probability of getting 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we look at it, the probability of getting 2 and 12 is the same, and it just increases, right? This is the probability. And it's just how it's distributed among all of its possible values. And all of their possible values are called random variables. And let's get into this definition. Probability distribution, the probabilities of all possible outcomes. If we looked here, it was from 2 to 12, all possible outcomes of my experiment of rolling two dice or sample space. What's a random variable? A quantity that can have a range of arbitrary means random, values denoted x. So these are my random variables over here. These are my random variables over here. Except it starts at, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, and then we get to what is a discrete random variable versus a continuous random variable. And the difference between these two is a variable that can only have certain values and a variable that can have an infinite number of possible values within a range usually. So an example of random variables or discrete random variables is like the dice example, or heads and tails, or rolling two dice. You have 2 to 12, but not everything in between. And a continuous random variable could be like height. Like I could be 175 centimeters or 175.4 or 175.481. So it's continuous. There's an infinite number of possible values within a range, right? So from 0 to, I don't know, let's say the tallest human is 3 meters or even 4 meters, which is not possible, I don't think, but let's just pretend. Right, so it's any number of things between there. All right, so that's what we know what a probability distribution is. All possible outcomes, random variables, all the variables at the bottom. What could my values be? It's the range. And it could be discrete, which means specific values, or it could be continuous, which is a range of values. Right? Now, here's an example. I have a table, gives a percent breakdown of the number of rooms of apartments in a particular complex. We're going to say identify the random variable. And we're going to construct a probability histogram, which is the graph for this. And then we're going to explain the meaning of the individual bars. And then we're going to describe the distribution. Then we're going to calculate the sum of probabilities. Does this confirm the result in the example? So we'll start with identify the random variables. It's number of rooms in the apartment complex. And it's a discrete number, right? I can't have 2.5, well, maybe 2.5, but I can't have 2.459 rooms. Okay, so this is my probability histogram right here, in that I have 15% with, we'll write this here, 2 rooms. We have 3 rooms is 30%, right? 4 rooms is around 42%. And then 5 rooms is about 10%. And 6 rooms is 3% right there. So that's my probability histogram. So explain the meanings of the bar in the histogram. The area of each bar represents the probability. So the area under here, it's 1 times 15, is the probability. Now, if I calculated the area of my all the histograms, it should equal to 100%. I'm not sure what that's there. Now describe the distribution. the probability increases and then drops sharply and then decreases after that. Calculate the sum of the probabilities and make sure that it confirm the results of the example. Okay, so if I add all these values, it should equal to 100%. So the cases cover every case in the sample. The cases cover every case in the sample. So that falls in line with what a probability distribution is. Okay, so here's something else. We're going to learn about a weighted mean, which means an average, a weighted average, a mean of a set of numbers that are given weightings based on their frequency. Multiply each number by its weight and divide by the sum of the weights. All right, and we're going to talk about expected value. Now, expected value is a probability distribution. Of a probability distribution is the predicted average of all possible outcomes. Expected value is equal to the sum of the products of each outcome. And this is the formula. And if this scares you, this just means these are all possible outcomes. We're going to add them. That's what that means. That's what this means right here. It means we're going to add all possible outcomes of an outcome multiplied by the probability of that outcome. And it's best to do examples. So if I have a spinner as two equal sectors colored red and blue, we're going to just go ahead and follow these steps. We're going to make a tree diagram to show the probability distribution for the number of times the spinner lands on blue when it's spun 4 times. So we're going to spin the spinner 4 times. I have red on this side and I'll have blue on the other side. And we're going to spin the spinner 4 times. We're going to spin the spinner 4 times. And we're going to make a probability distribution of, does it land on blue 0 times, 1 time, 2 times, 3 times, and 4 times. Make a probability histogram for this distribution. And then we're going to calculate the expected number of times the spinner lands on blue. And then interpret the results. Okay, so let's take a look at this tree diagram. So we're going to make a tree diagram. And here it is. We have blue, blue. Let's change this to red. We have blue, 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 red, blue. We have blue, 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 red. And that's what that represents. Right? So red, blue, blue, blue. As you can see, we always go blue and red and blue, red and blue, red and blue. Okay? So that's our probability tree. Now we're going to make a probability histogram for the distribution. So we have to find the probability of all blues. So how many blues do we have? When we have 4 blues, we only have 1. The frequency is 1. If we have 3 blues, well, these are all the circumstances where I have 3 blues, right? So that's blue, blue, blue. That's blue, blue, red, blue, right there. That is blue, red, blue, blue. And then finally blue, 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 red. So there's a frequency of 4 times. And then we have 2 blues. It happens 6 times. And then 1 blue. It happens 4 times. And then no blues. It's just 1 time. And we calculate these probabilities by saying 1 divided by 16 outcomes. We get 6.25. 4 divided by 16, well, 4 over 16 is 25%. That's kind of obvious. And we just calculate the probabilities, right? Our frequency is 1 over 16, 4 over 16, 6 over 16, etc., etc. And if we graph this, right, these are number of occurrences of blue. That's just over 5. That's 25% there. And that's 37.5% for it occurring twice. Now calculate the expected number of times a spinner lands on blue. So when I spin it 4 times, I can expect it to land on blue. Well, we have to calculate the expected value. So how do we do that? Well, we have a formula for it. And now this just says add up all for every outcome. Add them up. Add what up? Add that up. The outcome multiplied by the probability of that outcome. The outcome multiplied by the probability of that outcome. We get 4 times 6.25%. That's that. Then we have to do this. Here, this outcome. That's another outcome. We're going to add 3 and 25%. 3 and 25%. Next, we add 2 times 37.5%. We add 2 times 3.5%. Then we add 1 times 25%. That's right there. And like I said, if this scares you, all you have to say is that we're going to add up this for all outcomes. And I just runs from 1 to n, which means every single one. Start at the first one, end at the last one, add up the outcome multiplied by the probability of that outcome. And then finally we have the last outcome, 0 times 6.25. Well, that's going to end up equaling 0. So we do that math. 0.25 comes from there. 3 is 0.75. 2 times that is 0.75. 1 times 0.25 is there. And 0 times anything is 0. So when we add them up, we get an expected value of 2. Now, take a look at our graph again. We're going to take a look at this graph right here. And if you think about it, if these two are equal, if I was to draw a line in the middle, it's almost like the average of the probability distribution is right here in the middle, and that would be the expected value. Okay, so I'm just going to move back on to the next part. Okay, so interpret the results in part C. So if expected value of x, then I should expect to get a value of 2 blues if I spin 4 times. Now, what does that mean? Another way of saying it is if I spin the spinner 4 times, so I did 4 trials, and repeated spinning forever, and I rolled it another 4 times, and another 4 times. Let's say I got 0 blues. This one I got 2 blues. This time I got 4 blues. The next time I get, I spin 4 times, I get 3 blues. On average, if I continued this to infinity, I would get an average of 2 times blue. I would get blue 2 times on average. And that's what expected value means. If you continue to do it, what can you expect on average to get? And that's 2. So another example of calculating expected value. So I have a lottery, it has $10 million. And that's the grand prize. And then second prize is $500,000. And then third prize is $50,000. And there's 10 of them. And 10 $50,000 prizes. A ticket costs $5. And 4,000 tickets were sold. What is the expected value of each ticket? So after you buy it, what's the expected value? So expected value is for every single outcome, multiply the outcome, add up the product of the outcome times the probability of that outcome. So let's take a look at that. What's the one probability? What's one outcome? Is 10 million. And the probability of that outcome is 1 over 4 million. So that's outcome times the probability of that outcome. Then we add the next outcome times, which is 500,000 times, there's 1 in 4 million chance to win. There's 1 prize out of 4 million. So that's the probability of winning. plus 50,000 times, there's 10 out of 4 million chances to win. So that's every possible value. And actually, plus 0 times, well, I don't know. Basically, it's the rest one. But 0 times anything is 0, so we'll just skip it. And we'll do a little bit of math. We cross out the 10,000. Oops, there's a 40 there. So we get 10 over 4. We get 5 over 40. And then we get 5 over 40 again. And then we add them up and we get 2.75. So our lottery is a good investment. Well, after I own it, it's worth $2.75, right? Multiply the probability times the outcome, I get 2.75, but I paid $5. Is it a good investment to own it? Well, the answer is twofold. Yes, it is if you're selling, but no, it's not if you're buying. So you're going to have to pay $5 for something worth 2.75. So it's not worth it. It's not a good investment. And that's it for probability distribution.